Hey guys, we're back with lesson 2-6, graphing on the coordinate plane, and in this lesson we're going to practice graphing some more from slope-intercept form. And let's look at our first example here. In our first example, you'll notice that the equation is not in slope-intercept form. If you'll recall, slope-intercept form is y is equal to mx plus b. This equation is not in slope-intercept form because y is not by itself. So that'll happen often, and when it does happen, we have to rearrange so that it is in slope-intercept form, so it makes it a whole lot easier to work with. So we're going to solve for y. If you need a little review over that, that's in lesson 5, not lesson 6, so you can go ahead and change that number in your notes. We did a little bit of moving around, and so you can change that. It's back to lesson 5. Okay, so that's the first step, is we're going to make sure that it's in slope-intercept form. Once we've got it in slope-intercept form, we're going to pick out the m value and the b value. Okay, to remember, the m is the slope, and it's always married to the x, so they're both the letter m. That might help you a little bit. And the b is always by itself, the b being by itself. And that might just be a couple of things to help you be able to pick those out. So this particular equation is not in slope-intercept form, so we're going to have to get it in slope-intercept form before we start. So if we write down the equation over here, so we have just a little bit more room to work with, 3x plus 4y is equal to 8. Now, there's two things here that we've got to get rid of, the 3x and the 4, so that y will be by itself. Remember, we go order of operations backwards, so we have to get rid of the addition or subtraction. So we're going to subtract 3x. That'll make those things disappear because 3x minus 3x goes to 0. But if you do it to one side of the equation, you have to do it to the other side of the equation. So we're going to subtract 3x from both sides. Here, that's 0, and we're left with 4y is equal to 8 minus 3x. Now, still not by itself, we need to divide by 4 because it's being multiplied. And remember, whatever you do to one side, you have to do to the other, and we have to do it to the whole side. Let's go ahead and break it apart and do it to each part. 4 divided by 4 is 1y. 8 divided by 4 is 2. And 3 divided by 4 doesn't go into it evenly, so we're going to leave it as our fraction. If you'll remember slope, we want written as a fraction because it's a rise over our run, and that'll make it easier. If you go up here, it looks very much like slope-intercept form. Y is by itself, but if we switch the places right here and brought our x out first, some people might want to do that so that they'll remember that, oops, there is a button on my little thing up here that makes this thing go across, and it really g's crazy. So let me see if I can get rid of that line. Okay, pick my pen back up. Okay. So we're going to rearrange it so that the x value, the slope, is first, and it's exactly in slope-intercept form. That's not something I often do because I remember the slope is the one that's attached to the x, the y-intercept is the one that's by itself. I don't remember where they're located. It doesn't really matter where they're located here. It's what they're attached to. So if we look at this, now that we've got it in slope-intercept form, we can pick out the m and the b, So over here on our steps, so to graph, we begin with our y, or our b, which is our slope-intercept. Okay, so we're going to begin with our b, which is slope-intercept. And if we look at that, after we get that, we're going to need our slope, which is our rise and our run. That's our m value. So I'm going to go ahead and write those things down over here. And my m, my slope, is a -3/4. And my b, or my y-intercept, is 0, 2. So we're going to plot those points. I'm going to change the color of my pen. So we got y-intercept is 0, 2, so we'll put a dot there. From that point, we use our slope, and that's the rise and the run. So we're going to go, since it's negative, we're going to go down 3, and the y is, the x value is positive, so we're going to run to the right 4. So we're going to go down 3 units, 1, 2, 3, and to the right 4 units, 1, 2, 3, 4. We're here. We can continue that pattern, and if we do, we run out of our grid, but it would be down here somewhere. And we're going to also go in the opposite direction so we can get a good line, not just 2 points here. We want as many as we can possibly fit on this coordinate plane. So instead of going down, we're reversing it, and we're going to go up 3 units, 1, 2, 3, and to the right 4 units, 1, 2, 3, 4. And so that would be our next point. They'll fall in line right there. And we can do that because the slope is negative. A negative 3 over the 4 is the same as a positive 3 over a negative 4. It's still a negative number. It's still a negative number 3/4. And if you remember that you can always put a negative in the top, in the bottom, or out in front of the whole fraction, it doesn't make a difference. Okay. The last thing that we're going to do is, once we have those two things, we're going to draw as many points in as we can, and after that we'll connect our dots and draw our line. So I'm going to use the line feature here and hopefully draw in those lines, connecting our dots. Remember, these are not the only solutions, so we're going to go back and put arrows on our line to show that it continues on in both directions. Okay, let's go to the next slide. And here you'll find 2 U-tries. On these, you'll see that neither one is in slope-intercept form, so the first thing you need to do is solve for y. I'll write up here, remember slope-intercept form is y is equal to mx plus b. So get y by itself, then pick out your m value and your b value, your y-intercept, and make sure that you practice each one of those. Go back and check and make sure that you got your graph correct. Ask any questions if you get them wrong, and I'm going to pause here and give you time to do that.